then maybe we can get the rest of them on there so that they can help you guys. Otherwise, you guys are gonna have some smaller groups. So the basic thing with polarity is you've got to be able to draw the model. So if we have PCl3, who's going in the center? PCl3, who's in the center? I'll give you guys some time to open it up if that's what you need to do. PCl3. Is it P or Cl going in the center? P, right? P is unique, so P is going in the center. We're going to put Cl's around it. Now we need to add up the total number of electrons available. P is in group 5A, so that's 5. Cl is in group 7A, so that's 21 because we have 3 of them. 21 plus 5 is 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So I'm quite confident that that is the Lewis structure of PCl3. With that, can somebody give me the shape of PCl3? How about the bonded atoms to the central atom? How many bonded atoms are there on the central atom? 3. Very good. We have 1 lone pair and 3 bonded atoms. So this is trigonal pyramidal. What's the angle for that? Very good. So there we have all the information except for the last thing that you need for the laboratory. So that's basically what you need to do. The last thing you need to do is you have 2 more things. Second to last thing to do is you need to figure out if that is polar. In order to do that, we have to find each of these bonds and figure out if they're polar or non-polar. Well, all of these bonds are the same, so if one's polar, they're all polar. If they're non-polar, then they're all non-polar. So PCl, P is 2.1, Cl is 3.0. So what's the difference between 3 and 2.1? 3 minus 2.1. 0.9. Does that fall in our non-polar, polar, or ionic? What's that, Ka? What is it? Ionic? 0.9? Non-polar, polar, or ionic? 0.9 falls between 0.5 and 1.9. So that is polar covalent. Now, here's the question though. Remember, they are polar bonds, but do they cancel? That's what you need the model for. So if we take a look, the model shows it like this. That means I could have drawn this like this. And it might look like one's pulling that way, one's pulling this way, and one's pulling this way, so that they all cancel. The problem with that is there's this lone pair on the top. That pushes these guys downward. That pushes these guys downward. So in reality, they're not just going against each other on a flat plane. They're going downward. What that means is there's no pull pulling back upward. The fact that we have this lone pair, there's no pull there. So that means that this is polar. Let's try BCl3. Who's in the center of BCl3? Who's in the center of BCl3? Boron. And we have Cl here, and Cl here. We have 3 plus 21. This is 24 this time. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Remember, boron is an exception. The boron actually is fine with just having 6 for its octet. It was one of the exceptions we talked about. So we have 1, 2, 3 bonds and 0 unshared pairs. What is our shape here for 3 bonds and 0 unshared pairs? Three bonds, 0 unshared pairs. If you're unsure, you can always look at the back page. Trigonal planar. What's the angles on that? 120. So the difference about this is it's planar. So the fact that it's planar, that means that all of these CLs are on the same plane. Now, if you look at these, the way I've drawn it, it's fine. But in reality, this probably should look like it's coming down more because they're all 120. I look like I have 90, 90, and 180. If we look at all of these as being, I have the right one. If we look at all of these as being 120, we're going to get something like this, right? The fact that they are on a plane means that these two will pull out this way, and this one will pull the other way. So these two will pull out the left and right, and this one will pull out the down. So basically, they will sit there and cancel all of each other. If we had something pulling this way, and this way, all with equal forces, this center part would not move. The electrons are going to be pulled equally in all directions. Let's try this one. Who's in the center? CH2F2. Which one's in the center though? C or H? C. H cannot be in the center, right? So we are going to get this structure, and that is a tetrahedral. That is a tetrahedral. Now looking at this, if we look at these bonds, F is 4 and C is 2.5. That's 1.5. So these bonds are polar. 1.5. Now looking at the structure, it looks like those cancel each other out. One goes right, one goes left. But is tetrahedral flat? No. So it's not just going right or left. One's going this way and the other one's going that way. Well, both of my thumbs are pointing which direction? Up. Both of my thumbs are pointing up. That means there's no pull in the downward direction. That means that this is polar. The electrons are not canceling, the electron pull is not canceling out. That means it is polar. CS2. Look at the structure of this. This is linear. So if the pull is out in that direction and that direction, they are going to cancel each other out. That is non-polar. Non-polar. How about this one? This is formaldehyde. We do have trigonal planar. And if we recall, trigonal planar up here was canceled out because all of these bonds were polar. Well, looking here, only one of these bonds is polar, and that is the carbon-oxygen bond. So basically this oxygen is going to pull the electrons in that direction. When it pulls the electrons in that direction, that is going to make those electrons move, and that is polar. CH3OH. This is methanol. And yeah, this oxygen is going to pull the electrons this way and this way. So that is going to be polar. Remember, are they polar bonds? Yes. If they don't cancel, then it's polar. C3H8, well, the first question is going to be the answer for this one. Are these polar bonds? No. These are non-polar bonds. The electronegativity difference is not high enough. That is non-polar. Non-polar. All right, so we have our project today. Let's take a look at that. Yeah, the Vesper lab. So if you click here, students will build this. The Vesper, remember, stands for valence shell electron pair repulsion. So what's that? It's locked. Oh, let me open it then. Available on stay. There we go. Cool. So obviously we are not you know, some people are in here and some people are not. But you do want to make sure that you contribute. So maybe the people at home at least make models with some of the stuff they have. You guys are more than welcome to use stuff in here like toothpicks and stuff. But basically what we'll want, how we'll submit this is you will have pictures of your molecules. You have to make 6 and you must turn in the key. So this is the key. Let's just pick on this one, this first one. So I need to make the Lewis structure of CO. I need to tell the geometry, and then I need to tell whether it's polar or non-polar. And then I need to make a CO model. Same thing with NO2, SO3, NH4, CCl4, BeCl2. So you're given 6 of the molecules. You know, you can have one person go through and start making Lewis structures. After that person gets done with the Lewis structures, the next person can get the geometry. And then hopefully you have a polar, non-polar person, and they can help explain to you why something's polar or non-polar. And then you're going to basically have to have a builder as well. So you can divvy out these jobs. I'm not going to assign those. Keep in mind these little rules here on the assignment. If the group thinks that you didn't contribute or whatnot, then you can do the whole thing on your own. Tomorrow is day 1 of the lab. So if you're absent tomorrow, you will be able to join a group on day 2, which is asynchronous Monday, if they can find you. Yeah, if you're absent on asynchronous day, then you'll have to construct this all on your own. Since it is asynchronous, basically I will just open up the what is it called? The canvas all day and have groups on there, and then you'll be able to join into those groups, just picking into them. And the groups should be based on these numbers. So we can assign group numbers today, and then basically you just stick with the same group. The other things is your atoms and your compounds should be correct in relative size. So remember, fluorine is the smallest and francium is the biggest. So it doesn't have to be dead on that. Just try to think about those. Lone pairs must be represented. I'm going to put on the center atom only. So I don't really care about lone pairs on the outer atoms because that gets hard. The center atom only. There we go. So that means that if you are dealing with this right here molecule, you would put the lone pairs on the central one, but you don't have to worry about it on all the other ones on the outside. Correct shape. So table 2 is that last table at the back. If you take a look here, here are those shapes. They show you the stick figured shapes. Those of you in here, please use non-perishable items in case we hang them up. Resonance, if it shows resonance, all you have to do is draw it on the key, which is this thing. You have to draw it on the key here, like if it shows resonance, but you don't have to make multiple models of that. Questions? Any questions? No, you want to do it all by your own? Yeah. Let me show you what the final project looks like turned in. Just so we understand that we're all on the same page with this. Bonding, Vesper Lab. Boom. Come on, where is it? There we go. So basically, you have the key filled out with all that information. And then you have a second file with the pics. So there's his pick. He used gumdrops or gummy guys. There's his pick. Notice he used a stick for the lone pair. Right? So that's the idea. And you will have, looks like his partner. His partner must have the other 3. It looks like they split them. So that means Owen Smith will go to Owens. And Owen will have the other 3. Yep, there we go. He used marshmallows and then he painted them to show the sizes. But that's the idea. You should have 6 drawings and 1 key. You have the key, and then you have, she used Play-Doh. Then you have 6 models. Play-Doh's pretty heavy, but she's got a nice key here. Yeah, Play-Doh's heavy. Yeah. Oh, there you go. Sour gummy guys. Those are pretty easy. Dots are pretty cool. But that's just to give you an idea of how the project should turn out in the end. So we've got, we only have how many groups in this one? We only have 5 groups in this one. So I'm going to separate the breakout rooms into, actually, let's just go with, are you guys all logged onto this? Are you guys all in there? No? All right. Go ahead and get in there. Then we'll make, looks like we only have Sydney, Michaela, Kennedy. So we only need like 3 breakout rooms. Oh, need more than 2. We only need 3. I will let you guys pick who you want to work with. I don't care at all on that. So there are the 3 breakout rooms, and that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 2 or 3 people per. Because they're more than welcome to grab in any of those breakout rooms you want, and then you guys can start discussing. I suggest you use headphones in class. It's easier. If you have a question, by all means, get my attention. We can go from there. Would you guys in here like for me to print out like a hard copy of these? Yeah. So which group are you joining? You want to work by yourself? Which group? 4. Okay. You? Hard copy? Yeah. And hard copy? Let's just, why don't you guys just join group 1 then? So we have some people that want to work alone. So those, you don't have to work with somebody that's here if you're at home. So Lena and Kennedy, if you guys want to join a group, you don't have to work with somebody that's here, but you're more than welcome to as well. So I'm going to print some of these out real quick. That looks like junk. I'm going to stop recording.